Assalamu alaikum and greetings everyone. We are group C2G01 from the course Capstone project SKE4723, and our topic for the project is Smart Agriculture System, where we chose to develop a smart monitoring and feeding system and named our product MAC, Monitor Analyze Quality. We are a group of 4 members, and our group members are Alexander Anderson, Anik Anthony, Nick Marisa binti Nick Mazlan, Ahmed Fadila bin Pitkari, and Adib Muhammad. We are under the supervision of Dr. Noor Muazza binti Abdul Latif. We have divided this presentation into 4 contents, which include product development process, features and operations, data collection, and findings from end users.
After doing intensive research for 5 weeks on the aquaculture sector, we found that most small-scale fish farmers were longing for a device that can monitor their fish farm and alert them remotely, and most importantly, it doesn't cost that much. Thus, we asked ourselves, how can we have an affordable monitoring system of an aquaculture farm with app supervision? Hence, after intensive brainstorming and complex engineering, we introduced to you MAC, a state-of-the-art device that can not only monitor the water quality, but also auto-feed the fish at a set time interval without the farmer worrying about anything. Its name is incorporated from the features and objectives it carries. Firstly, the device monitors the pH and temperature of the fish farm. By having these features, this device allows the farmer to ensure that the water quality is excellent, allowing the farmers to attain maximum growth and production of fish. Apart from its features, what is so unique about our product MAC? First of all, the product is quite affordable, cost at best around 250 ringgit Malaysia. Furthermore, the product is portable and weighs only about 1 kilogram, so easy to carry. It has remote monitoring features since all the data from the sensors are sent to the Blink cloud and can be monitored from the Blink app over a smartphone. The instruction for this eco-friendly device comes with a maintenance checklist just like any others. Lastly, it reduces the labor's expense since the device monitors water quality and feeds the fish automatically. The first 5 weeks was the conceiving phase, where we did research on who our clients are by interviewing them. Then we come out with a conceptual prototype. Overall, we specified the product we are going to develop and features it would have in this phase. The next 2 weeks, we started the product development process, where we researched the sensors we would be installing or using in our product. Following weeks, we sketched the hardware, made the electronic circuit drawing, purchased and assembled the hardware. In the next week, we developed the Blink apps that would integrate with our device and tested the app and hardware synchronization. Finally, the last 2 weeks, we were in the final phase of our product development, where we carried out real-time testing of the data collection from the device to the app to our smartphone or laptop, final troubleshooting to make our product bug-free, and finalize the device.
Features and operation. In this section, we will explain the features of our product in detail and how the device operates. Hardware specification. Our product consists of solar panel which allow the device to charge using solar energy, pH and temperature sensor for monitoring this parameter, LED indicators for indicating if the pH and temperature are optimum, SG90 micro servo motor which control the opening of the feeding pot, food tank to preserve the fish food, lithium battery level LED to indicate the battery life. Operational flowchart. So how does the device work? It starts with the RTC model obtaining the set time by the user to feed the fish and checks whether it is time to feed or not. Let's assume the user has set the feeding time to be at 8 am, 12 pm and 5 pm. When the time is the same as the specified time, the device checks whether the pH and temperature is optimum. If yes, the servo motor turns on and opens the food pot for 50 seconds. If the pH or temperature is not optimum, the red LED will turn on and alert the user, as well as the feeding system will not work. When the time is not in the allocated feeding time, but the pH and temperature are in the optimum range, the green LED will turn on. If the pH and temperature are not optimum, the red LED will turn on and again alert the user through the Blink app. Blink app and cloud. The device monitors pH and temperature and sends data every 15 minutes to the Blink cloud. All this can be viewed through the Blink app remotely in real time via smart device such as smartphone or laptop. Blink app and cloud. If the system shuts down unexpectedly, the app won't be able to retain any data, and after 1 minute, the Blink app will send a notification that the device went offline.
In this section, we'll be explaining a series of tests we carry out to ensure functioning of our product is robust. The first test is pH and temperature measurement. This test is carried out to determine if the system can measure the pH and temperature in different environments. Different solutions of the pH and temperature are used to immerse the two sensors. The parameters are observed through the cloud. The green LED will light up if either the parameter is inside the range, while the red LED will light up if it's outside the range. Hence, the device passed both test sensors. The second test is real-time pH and temperature monitoring. The purpose of this test is to determine if the system can monitor the farm continuously and provide real-time data. From the graph, it can be observed that the data is collected every 15 minutes time interval, meaning that ESP32 send the data to the blink cloud every 15 minutes. ESP32 lifespan will be extended as a result of this, since it will not transfer the data every second. The next test, factors affecting the solar panel efficiency. This test is carried out to identify the optimal operating condition for the solar panel based on the solar panel power efficiency. The power efficiency of the solar panel was calculated. From the result, it showed that under maximum sunlight at 12 p.m., the efficiency is the highest compared to the other condition and time. The next test is the performance and accuracy of the sensor. The purpose of this sensor is to determine the sensor performance and accuracy over the time. In this test, the result obtained from the sensor were compared with the calibrated reference devices for 7 different times. The results show an average pH sensor has an accuracy of 98.29% and the temperature sensor has an accuracy of 99.89%. The last test is the lifetime of the lithium battery. This test is done to calculate the estimate life of lithium battery in the system. Power consumption by the device in a day is calculated, and the power supply by 6 fully charged lithium battery in a day is calculated to find the numbers of the device can operate after being fully charged. From the result, it is estimated the device should run about 37 days before the battery are fully drained.
Findings from the end users, where we draw some conclusions from the test results. The device can measure a different range of scales in an accurate manner. The device sends data every 15 minutes in real time for the user to monitor. The solar panel works more efficiently when placed under the sunlight. The pH sensor has an accuracy of 98.29% and the temperature sensor has an accuracy of 99.89%. And lastly, the device can run about 37 days after fully charged. All these results prove our claims of the features and function of the device as well as durability and robustness. Moreover, our product comes with an instruction manual that provides safety information, how to start the MEC, how to monitor the MEC, data collections, maintenance, and specification. So, would you like to run your fish farm manually or automatically? Experience digital with us. All you need is fish with Mac.